Alright, welcome guys. Alright, today we're going to look at trace table. So we looked at algorithm and we said that an algorithm is basically a step-by-step process to solve a problem. So after you have created that algorithm, you are a pseudocode, you want to test it, right? So in testing it, we will create a trace table. So a trace table here that we have here is basically a table that is completed by tracing the instructions in an algorithm, right? So you're going to trace the instruction that is inside of the algorithm, and it is based on given data. So the given data will help you to solve that process. So we're looking at input data or test data that is going to help you to solve that trace table. Right? So when you are creating a trace table, you are going to identify your variables, and your variables are data that changes throughout your program, right? So you identify variable names. So we're going to look at that, and you use those variable names as the column heading to represent the changes that will take place throughout your algorithm, right? So you have a little algorithm here that we want to discuss, and then we get straight into solving the table that we have over here. So watch this. This is our short algorithm that we have here, and I'm going to run through a few basics. And we know that read represents our input stage, right? So we have input, and we are going to follow this entry here. It says for j equal 1 to n2. For represents a definite type of loop. So a loop basically tells you that you're going to execute this set of instructions for a certain amount of time, right? And it says for j equal 1 to n2, we have the starting value and we need to know the end value. If we fast track a little, n in our table that we are going to be using, n is going to represent 6. So we are going to move from 1 to 6. So that is the amount of time we're going to execute it 6 times. So this instruction will be executed 6 times based on our loop that we have here. So we have our loop right here. From the loop, we have an if statement in our program here, and we know that if statement allows for selection to take place, right? So the selection here is that we have two options. The two options that are here is one, S will be calculated from this process, and 2S can either be calculated from this process. So at this stage here, that is known as your condition. So the condition is j must be less than 5 for you to do either 1 or 2. J must always be less than 5. So that's the condition in this question here. So if j is less than 5, then you can proceed to either stage 1, else you can proceed to stage 2, right? So let us execute this algorithm within our trace table. So we have our input value starting with n to the 6, right? So our n value here from the first part of the algorithm, we move from 1 to 6. So it says j can have values from 1 to 6. So I can fill out j to be from 1 to 6. So we complete that stage for j. So it means that we are going to execute this loop 6 times. So we're going to complete that step. So in completing it, we are only determining the value for s. And s can change depending on the condition here. So let us run the condition now. Our first value of j would have been 1. is 1 less than 5? Yes. So we'll go to the first option. So the first option is normally true, and the second option is if it is false. So is 1 less than 5? Yes. So we do the calculation to find S. N originally is 6 plus the 1 that we have here, so will give us 7. 7 times 2 will give us 14, and that's the first calculation. And for when you have completed the process, remember that we are going based on our loop, so we need to execute it another time. So J value will still be 2, and 2 is less than 5. Yes. So we do the calculation again. N is originally 6 and J is 2, so we add 6 plus 2 give us 8. 8 times 2 will give us 16. Now we'll continue the process. To compare, you must always compare against this condition. So we'll compare again. Is 3 less than 5? Yes, so we continue. N is still what? 6 plus 3, 9. 9 times 2 is 18. And we continue again. Is 4 less than 5? Yes, continue again. N is 6 plus 4 give us 10 times 2. We get up with 20. Now we compare this one now. 5 for J. Is 5 less than 5? No, 5 is not less than 5. So that is false. When it is false, you go to the other option which says else. You are going to use this condition now. So the value of N is 6 minus J, which is 5. Take that, we are left with 1 times what? 2. The asterisk means times. 1 times 2 give us back 2. I will continue one more time. Is 6 less than 5? That's false. 6 is not less than 5, so we continue to the else option. And we will say here 6, and I will take away J, which is original, another 6. 6 from 6 will leave us with 0. And 0 times any number will end up back with 0. So that's how you would complete your trace table. For us to design this trace table or to create a table here first, we ensure that these values or these letters represent the variable that is going to change. So if we identify the variable n in this, we know that n will change. It will have a change in value as we go along. N will remain the constant value here. Sorry about that. N will remain the constant value, and J will change here. So it's an input value, but it is changing. And we look at J, which changes, S, which changes. So we identify all our variables and create column headings, and then we execute this algorithm here. So that's how we trace the instructions from the algorithm into our trace table over here. That's it.